Shall we start now?
Yes.
So good afternoon to everyone. I welcome to all of you in talk number 17 of weekend webinar series of Windows of Opportunity in Science and Engineering, organized by Indian National Young Academy of Sciences, INIAS, and Indian National Science Academy, INSA, Mumbai chapter. The detail of both INSA and INIAS can be found on these web links, and all these talks are available on the INIAS YouTube. So we have started this series, I think in beginning of April. Until now, we have covered the 16 talks. So I will briefly, so here in the 16th, so we have started from the 3rd April and the 16th talk was on the last weekend on 24th July. And we have discussed, we have covered from the engineering science to basic science to multidisciplinary science to interdisciplinary, including environmental science and engineering, biomedical engineering, space science, aquatic geochemistry, economics, health sectors, life science. So if you are interested in any of the subjects, all the talks are available on YouTube. And you have to go on INIAS YouTube, search and then look in the playlist of Windows of Opportunity in Science and Engineering. And you will get all the talks the covered by in this webinar series. So today on the 17th talk, we have eminent speaker, Dr. Somnath Datta from India Meteorological Department, and he will be discussed about the career opportunity in meteorology. So Dr. Datta is now head of Meteorological Training Institute. He did PhD in applied mathematics and is looking after entire training activities, training policy, training circular, development and overall human resource development of India Meteorology Department. He has carried out extensive research on atmosphere, energetic, collective instability and dynamics of airflow across orography and numerical weather predictor. With this brief introduction, I would like to invite Dr. Somnath Datta for his talk. Sir, Dr. Datta, session over to you.
Thank you to the organizer, and special thanks to Dr. Anup Mahajan, my friend from IITM, for giving me an opportunity to talk with budding scientists, budding science students of our country. So I am not going to make any presentation. I will just discuss with you. Rather, I can tell that instead of a talk, we can say in Bengali, we say Alochona Chakra. And we will just discuss with you. In between, you may stop me, you may ask me also question. So the topic is opportunities in meteorology. Now, opportunities in any, before discussing opportunities in any field, first of all, we should know what is being done in meteorology. In meteorology, basically, what it is done, you know, that is the forecasting weather and climate. Forecasting weather and climate. As such, dictionary meaning of the meteorology is science of weather forecasting. And in weather forecasting, what we do, from the complete information about the present state of the atmosphere or present condition of the atmosphere, we try to tell what will be the future state of the atmosphere at some location. And if we consider, rather we have to consider, it is so that atmosphere is a dynamical system, and being a dynamical system, it has a time evolution, and naturally scientists and all users would like to predict such dynamical system. And we all know, it is known that for predicting any dynamical system, we require two things. One is the rules which governs the time evolution of the system, and rule or rules, set of rules. And another one thing is required, that what is the complete information about the dynamical system at the present state, and which is technically called the initial condition. So as a result of which, prediction of a dynamical system, including our atmosphere, is nothing but an initial value problem. Uh, now, now, uh, now when we are predicting the weather, then we may predict the weather for 1 day, 2 day, 3 day, 1 week, 2 week, etc. Even when we are predicting the climate, we predict for a season. We are seasonal prediction, decadal prediction, and for climate change, we give the projection. Okay. Acha. Now prediction of, as I told you, the prediction of the weather or prediction of the climate, basically it involves solving a set of initial value problem, solving a set of initial value problem. Now, and we all know that initial value problem, basically these are set of differential equations, and the variables of this set of differential equations, they are nothing but three components of the wind, then temperature, then density, and the specific humidity, that is humidity. These are the differential equations, and another one equation is also there which makes the system closed, that is your equation of state. Pressure is equal to density into gas constant into absolute temperature. Okay, so therefore, for prediction of the weather, what we do in meteorology, we solve these equations. Now in these equations, on the left hand side, we are having the tendency, that is your first order partial derivatives of all these variables with respect to time, and on the right hand side, all the forcing terms are there. All the different forcing terms are there. Now, for solving this equation, you can understand, solving this equation, there are certain problems are there. The basic problem is the nature of these equations. They are basically nonlinear partial differential equations with the variable coefficients for which we don't have any analytical expression, and but we have their values at different time and at different point. So therefore the exact solution of such equations we cannot have the exact solution. Rather, sometimes we say analytical solution is not possible. So therefore we go ahead for the numerical methods. Now in the numerical methods, what happened? All the derivatives we approximate using finite difference scheme. And now using so we can understand lot of applications of mathematics is there. Very much application of mathematics is there. So this is the first thing. So in meteorology, people with mathematics background has lot of scope in this field, meteorology. because solving these equations using numerical method, it's a really very challenge. Very challenge means what happened when we are approximating any derivative, special derivative, specific using some finite difference scheme, finite difference scheme. So that time we all know, that time generally what we would use the help of Taylor series, again mathematics. Now in the Taylor series up to which term we should keep, or that means where we should truncate, again there is mathematics is there. Mathematics is there. So there are a lot of applications of mathematics is there in this field. Then next thing is that we can understand even using these numerical methods, we cannot solve this equation manually. So for that actually lot of computer codes are prepared, because we need to generate forecast for thousands of points over the globe, thousands of points over the globe. So therefore it is not possible. The human cannot do this thing. So for the machine is required, and for to get the job from a machine, definitely you have to write a code. So you can understand that people, students with computer background has a lots of scope in this meteorology. Because what happened, suppose the equations are solved using certain computer language. It is fine, they are giving the solution, but thing is even with the very fastest available computer system, if we find that solutions of the equation, that means results are coming not at a particular time, because for issuing any forecast some lead time is required, and if that lead time is we are not getting, then that forecast will not be useful. So therefore it is required to make the code more efficient. Again the role of computer programmer is there. Now once upon a time all the codes were written in Fortran language. Now in Fortran language there are a lot of benefits are of course there, but one thing is that suppose the results you need to graphically depict at the same time, results will be prepared and it will be graphically depicted. Generally in Fortran language what happened then, what happened after getting this result, then using some other graphical package you can get the result. But there are now other new languages are coming, coding languages, just like your Python is coming, Python, then MATLAB is there, where those code, if it is written, then the graphical picture will be automated instantly at the same time, simultaneously it will be generated. So there is a need now. Those codes may need to transform into some other computationally efficient language. So again, the role of computer science people having lots of coding knowledge, lots of coding knowledge. I hope I have been able to explain the usefulness or scope of the mathematics background students and computer science background student also. Now thing is, now in the governing equations, you may find there are many terms. Rather, I should say one thing, that in the governing equations there are some terms are there. All those terms basically represent some process, physical process or dynamical process, which are mathematically represented by some term. That means we think that in the equations whatever terms are there, that means whatever terms we are comfortably can write, those physical processes represented by those terms are only responsible for the change of certain variables, just like what I mentioned, three components of the wind, temperature or pressure. They are only responsible. But It is not so. It is not so. Actually, there are many physical processes are taking place in the atmosphere. They are also very significantly influencing or playing very important role in the change of these variables. But unfortunately, those though unfortunately those physical processes are not always is not possible to be observed or captured. But thing is, even though we are not able to capture certain physical process, very small physical process, basically these are this type of physical process we call subgrid scale physical process. So subgrid scale physical process, generally they are able to be skipped, to be captured. But thing is, even though, but their effect on the grid is very significant. So therefore their effect need to be effect need to be incorporated in the model equations, in the model. Now for incorporation their effect, a clear cut understanding those physical process and accordingly a suitable mathematical representation is very much essential. So this is again the scope of the physics student. Actually meteorology, it is a physical science subject. The physics students application is everywhere. You see, whatever we all understand that in the atmosphere, whatever thermodynamic processes are there, even though we assume they are reversible process, but there are a lot of irreversibilities there. Now representing suitably this irreversibility, it's a challenge for the physics student. So physics student has a lot of scopes there. Now there is a new branch, that is atmospheric chemistry, because we all know that chemical substances present in the atmosphere or being injected in the clean atmosphere by us, that is very greatly influencing the atmospheric circulation and atmospheric behavior, which we see very much, that is your climate change, global warming, all these things we can see. So now how when not only that is ozone hole, all these things, there are actually lot of chemistry is involved. Now chemistry of those processes, clear cut understanding of those chemical processes is very much essential, and which can be done by chemistry students only. So chemistry has also very important role to play in meteorology. Atmospheric chemistry is nowadays it is a blooming field. Atmospheric chemistry is very important. Atmospheric chemistry. Even not only that, there are weather forecasting model. They have some chemistry version also. We are having one very famous popular weather forecasting model. We call it WRA. In short, we say WRA. This is nothing but weather research and forecasting model. Now we have a model WRF came, that it is a chemistry version of the WRF. Now in the chemistry version of the WRF, chemistry student has an intense role to play. So now situation is like that, no one can do anything alone in the atmospheric science, in meteorology. There should be an integration of all field. There we need person from mathematics, person from computer science, person from physics, person from chemistry. Now there is another one branch that is called biometeorology. There are a lot of applications. Biological impact is also there. By effect of the biological phenomena is also there in meteorology. I am not an expert in that. Well, I hope that some lecture you may be able to see that is your effect of the biological phenomena in meteorology. That also you will see. it is there. It is already documented. Many experts are there in our country. So biology has also a very important role to play in meteorology. So biology students has also lots of scope in meteorology. It is not the previous case. That is 50 or 80 years back. That time, even when we joined in our department, that time also I am telling you, that is people from physics background, people from mathematics background, they were mainly entertained, and people from, if anybody from meteorology or atmospheric science. But now people from biology, people from oceanography, people from your chemistry, they are also equally entertained, because everybody's integrated knowledge is required to make a perfect, whatever possible, perfect uh, atmospheric forecast model. Because all effects should, because you see one thing, in change of any meteorological parameter is due to all the processes, due to biological process, due to physical process, due to chemical process, etc. Now biological process, for representing a biological process mathematically in a relatively more correctly, for that process, biological process should be understood properly, should be interpreted properly, then only it can be properly represented by some mathematical term. Otherwise whatever, we can use some mathematical term in the equation, but thing is that will not be proper, that will not be proper. Another one thing also, we all know that in, when I was talking about the initial value problem, in case of initial value problem, actually there are two concepts is there. One is called well post and ill post. Now we can say an initial value problem is well post if we can ensure that on the right hand side whatever terms are there, they are the only terms, and perfect terms which are representing the change of, which are responsible for the change of the quantity on the left hand side. But question is, it is not so in our meteorology. The governing equations, they are not perfect. Why they are not perfect? Because there are, as I told you, there are many physical processes, there are many chemical processes, there are many biological processes which are also responsible for the change of a particular meteorological parameter. Now, unless those processes are perfectly, correctly represented mathematically in those equations, then we cannot say this initial value problem is well posed. And that means that means I can say these our model equations, then in that case our model equation will be imperfect, incomplete. Now you can understand very well that if your model equations are not at all not perfect, then even though you can prepare very robust, very good initial condition, ultimately your forecast may not be correct as per the desire. So but for that, those processes should be understood properly, and those clear understanding of those process requires the involvement of the experts from that particular field. So I hope that I have been able to explain the scope of the biology students, biological students, I should say, then physics student, chemistry student, computer code. Now, in this field, lots of application of the IT is there, information technology is there, because ultimately, whatever product, whatever forecast you are generating, we have to remember this has to be disseminated to the stakeholders in a very simple way and very efficiently. And there is the role of information technology. How fast, how better, how best you can disseminate the forecast product so that the loss due to the weather hazard is minimized, rather desired it should be zero. So there is lots of application of IT is there. I have forgotten to mention about another one field, that is your statistics. statistics. Statistics has a very important role in meteorology. As such, very advanced level statistics is required to be applied, and that can be done if person from statistics background with very strong knowledge, if they are involved in this business, in this field. Now, one example of statistics I am giving you. One example. See, as I told you that when we try to give the forecast using the machine, that is your which we call numerical weather prediction, they are actually what happened, you know, we solve some initial value problem where the variables are the three components of the wind, density, temperature, and specific humidity, and those equations are basically coming from some basic conservation law which we are reading since our childhood, namely Newton's laws of motion, that is your conservation of linear momentum, then your conservation of mass, then conservation of energy. This is your first law of thermodynamics basically, and another one conservation law we use because in atmosphere we have lots of water vapor, and that is a very important constituent of the atmosphere. Okay, and that is the only bothering phenomena for the common people, because that is presence in amount of the presence of water vapor is a very important for us, for our living over this planet Earth. So there is one conservation law for the water vapor also, and another one law which also we know, this is the combination of Boyle's and Charles law, that is ideal gas equation. So these are the, now we can very easily see that if we able to solve this equation, we will be able to find out the future values of these parameters, that is three components of the wind, density, temperature, specific humidity, pressure, etc. But now it is a very simple thing. Now whether our stakeholders will be very happy if we tell the information about the future values of these variables? Definitely not. Definitely not. They are interested to know whether at a particular place fog will be there or not. If fog is there, whether it will be intense or moderate, whether at a place temperature will exceed 40 degrees centigrade, that is the temperature, from temperature it will come, it is fine. Whether there will be rain or not. If rain is there, it will be heavy rain or light rain. If rain is there, whether it will be over an isolated place or whatever. So whatever information stakeholders require, that information that informations are not the direct product from our forecasting model. So therefore, what we have to do? We have to set up relation. Between the forecast value of the basic meteorological parameter, which I just told, three components of the wind, temperature, pressure, density, and specific humidity, this basic meteorological parameter and the concerned weather. Suppose stakeholders X is interested about fog. That means I have to set up a functional relation between this specific weather, that is fog, and these parameters. Now, how this functional relation is set up? Setting up this functional relationship, it requires statistics. It is nothing but some regression equation, and we all regression equation, that means statistics is there. I have told in a very simple way, but there is lots of very high level statistics is required. Another one example also I can give you. Say, for example, we know that weather forecasting models, actually they generate products for different region. When the region of responsibility, for forecasting is over the globe, then we say it is a global model. Global model is nothing but it takes care of generating the forecast output for the entire globe. Okay. Now, entire globe, and there are some regional models also. Just like in India, Meteorological Department runs global model. Rather, I should say MOES, Ministry of Earth Science. It has a global model. that is global forecast system model. We say global forecast system model. Similarly, we are having regional model also. Regional model. There are many regional model. I need not to tell all this. And one example I have already mentioned, that is your weather research and forecasting model. This is a regional model. Now, whenever the forecast, for every forecast output is given with a specific resolution. That means, for example, global forecasting model, it is given or as a resolution of 12.5 kilometer, about 12 to 12.5 kilometer, 12.5 kilometer. Now, suppose if I want the forecast information of say 2 kilometer region, over a 2 kilometer, then what we have to do, that we have to generate product for this smaller scale spatial domain using the forecast for a relatively larger scale spatial domain. This is nothing, technically it is called downscaling. This downscaling also involves lot of statistics. Actually, if I go on telling the application of the statistics, I won't be able to finish in 1 hour. So I think whatever example I have given you, these are sufficient to explain the importance of the application of statistics, or the scopes of the students from statistics background in this field. Okay, so in this field. So lots of applications of statistics, and there are lots of challenges are also there. Now what happened? Another one example I can give you. You see that when we are attempting to forecast some weather phenomena, a specific weather phenomena for a particular future time at a given place, and for that, if I use only one set of initial condition, and using that one set of initial condition, if I use only one forecasting model, mathematical model, then definitely we can understand that we will get only one forecast. Okay, only one forecast, because we all know that a forecast is a function of the initial condition. So therefore, for a given initial condition, I can have only, and for a given model, I can have only one forecast for a given weather phenomena. Now, this type of forecast, this is called deterministic forecast. So maybe some more deterministic. Now, in this deterministic forecast, actually what happened, deterministic forecast, we have no scope. We have no scope to quantify or judge the uncertainty of the forecast hiding in the forecast. We have no scope. But it is a fact. It is a fact that uncertainties are very much there in a forecast. Because now question is, where is the uncertainty? Uncertainty is lying in two things. One is in the initial condition. Now, initial condition, it is not 100% perfect. Bringing perfection in the initial condition, lots of high level interpolation, all these things are there. There are lots of application of mathematics is there. Very high level mathematics is there. That is preparation of better and better initial condition. Because it is very simple thing. Let us consider my this screen. In this screen we are having 4 corner points. This point, this point, this point, this point. Okay. Let us call these are the 4 grid points. For the numerical forecasting, I want information at these 4 points. But what is the source of our information? Source of our informations are observations. Observations, where from we are getting the observations are getting from observatory, observing point, we call observatory. Observatories are very unevenly spaced. It may be here, it may be here, it may be here, it may be here. What I mean to say, the distance between 2 observatories are not uniform. But using such unevenly spaced data, rather if you ingest such unevenly spaced data into a system, that is in the computer model, then what will happen? It will simply blow up. It will simply blow up. That blow up means basically it will show some instability. When instead of giving the forecast future true picture of the atmosphere, it will give some noise. It will give some noise. This is not desirable. So that's why what happened, there is a very huge task of preparation of the initial condition input data at these grid points, and there lots of application of mathematics is there. Okay, lots of application of mathematics is there. Now, not only that, suppose you have prepared, and definitely we can understand when we are preparing the information at the grid points, which are evenly spaced, from the information available at unevenly spaced grid point, definitely we are applying some interpolation, maybe very high-fi top level interpolation, but interpolation is interpolation, and we all know that in every interpolation scheme certain assumptions are taken, and those assumptions may not be valid for that particular physical parameter. So therefore it's an error. These assumptions give some error in the prepared grid point, and if we don't care for this error, and with this error, if we allow this grid point information in the model, then what will happen, that instability will be there. Now, reason for the instability also very simple thing, because we all can understand this error is basically nothing but, in physically we can say, in terms of physics we can say these errors are nothing but your imbalance. That means by putting the values of the variables available at any grid point, prepared at any grid point, in any governing equation, left hand side is not equal to right hand side. Rather, I should say the difference of the left hand side and the right hand side exceeds certain tolerance limit. Then what will happen? This difference is nothing but it is an imbalance, because left hand side is also some forcing, right hand side is also some forcing. If they are not equal, that means there is an imbalance. We say that there is an imbalance between the model field and the observed field, and this imbalance which we have generated due to our computational procedure, this imbalance generally it drives some circulation, but this is not a realistic circulation. These are spurious circulation. We call it spurious wave. Now so therefore you can understand, if we don't care for these errors, then what will happen, that in the model at the initial stage itself you have inserted some spurious motion, and when you are integrating the model equation with respect to time, then this spurious circulation will amplify with time and they will propagate from one point to another one point, and in turn it will ultimately spoil the forecast. So definitely it is not desired. So therefore, removal of the error, removal of the error, this also involves lot of physics, lot of mathematics. Lot of physics and lot of mathematics is there. So I hope that I have been able to explain you people that in brief, at least, that what is being done in a meteorology, what is being done in a meteorology, and I tried to explain you that whatever are being done in meteorology, they are actually involvement of people from multidisciplinary field is very, very essential. And with this, I will stop now. Rather, I will be very much interested to hear from you. Thank you. Dr. Brenda Sharmaji, I think I should not talk more. Rather, if anybody is having any questions, there may be many questions. So I can address them.
Okay, sir. Thank you very much for the very excellent, scintillating talk. I I must admit many information which I didn't know earlier, and now I'm a bit familiar about the meteorology. So there are a few questions. One question from I am a final year student of PhD physics from IIT ISM Dhanbad. I work in field of material science and more specifically on detection and degradation of water pollutants in water. Can I get recruited as a scientist in IMD? Will my PhD work will be considered as a research experience? This is a question from Shefali Jaswal.
Actually, yeah, I understand. Her field is basically water quality. He's telling us it is water quality, no?
Yeah, detection and degradation of water pollutants in water.
Water pollutant in water. Actually, if I correctly understand, basically hard field, because there is another one field is there that is called hydrology. Although hydrology and meteorology, they are very much linked. That's why there is a field called hydrometeorology. But in the hydrometeorology, basically what we deal, that is your effect of the meteorological phenomena on hydrological phenomena. That means, for example, let us take one meteorological phenomena is heavy rain, and one hydrological phenomena is say flood. So in hydrometeorology, basically it deals with the relation between the meteorological phenomena and the hydrological phenomena. Actually, that is the field what you have mentioned, that is much suited in much. But one thing is that suppose the pollutant in the water, I hope and I believe also, presence of pollutant in the water has a very important role in the downstream flow of the water. So therefore, if it is possible, to parameterize means, I mean to say, if it is possible to mathematically represent the effects of the water pollutant in the water flow, then it will be a very important contribution in the hydrodynamic model means that is water flow model. So and nowadays, actually, hydrology and India Meteorological Department, India Meteorological Department, they are closely working. So definitely it has an application. But thing is, we have to do in this way. Direct application, if I say, then it is an irrigation department. But if you otherwise, if you want to apply it, then in that case, definitely you have to find out the physical cause, physical relation between the presence of water pollutant and the downstream flow of the water. If you know it clearly, then you have to try to parameterize this effect. Parameterization means this physical process you must be able to represent suitably by mathematical terms. And those terms will be some additional term in the hydrodynamic equation, that is flow equation. Along with me, I hope this is clear to her.
Yeah, I think so. Sure. So, Dr. Dutta, I have a very basic question, and I wonder many times. So, just you can clarify me more. Like when we go in abroad, we live in abroad, so we always watch the weather forecast, and we can plan accordingly our weekends and weekdays accordingly, and it's, I would say, pretty much consistent, more than 90%. So we can see evening 5 p.m. there will be a rain, so there will be rain. We will go with umbrella. Otherwise, we will not take umbrella. But till now in India, we don't see such a consistent weather forecast. What is where we are lacking?
No, actually, there is no lagging. It is the characteristics of this is due to the basic difference between tropical weather phenomena and extratropical weather phenomena. Whatever abroad you told, I hope these are extratropical country. That
Okay.
means extratropical country, the weather systems are very stable. And
Okay.
because tropical convection, tropical thunderstorm type activities are very less there.
Okay.
Very less there. And here actually tropics weather of the tropic is very much influenced by the tropical convection, and this tropical convection, rather organized convection, they release lots of heats in the atmosphere. What I point over the isolated place, and those heat basically they generate one type of flow that is called divergent flow. It is like this: in, up, out, down, like this, this type of flow. And this divergence circulation, and I am trying to explain it, this divergence circulation representation in the weather forecasting model is a very difficult task. It is a very difficult task, but now we are being able, because now you know that India Meteorological Department has procured lots of Doppler weather radar. We are having a very good radar network, and this Doppler weather radar, they are able to capture the divergent part of the wind. Actually, what happened, any physics student, applied mathematics student, or engineering student, mechanical engineering student, definitely they know that every vector field can be split into two parts. One is called rotational part, another one called the divergent part. Rotational part we are very comfortably we can represent, but divergent part capturing is a difficult task.
Okay.
Difficult task. So earlier it was very bad, but now it is very now it has improved a lot due to the availability of this Doppler weather radar. But still we are improving.
Thank you very much. So in this same connection, I have another question. The recent cloud burst in Konkan, where we have seen cities, village merge in 12 feet water. Also many landslides. Is it possible to give warning of such cloud burst today in advance, or at least few hours in advance?
See, first of all, right now I am not in a position to tell. Of course, I cannot say it is not possible. But I am not in a position to reply this question. You may have to approach to the specific expert on that.
Okay. Then one more question came to how physics graduate can enter into this field. Any particular entry level course?
I am telling you, course. No, now I will tell you that regarding the training course. First of all, I am telling you that India Meteorological Department runs different types of training courses of different durations. There are some training courses of 1 year duration whose course content is equivalent to masters, MTech in atmospheric science or meteorology of any university. Okay. There is some other courses, and for that actually, for this 1 year training course, the minimum qualification is masters, MSc in physics or MSc in mathematics, or BTech or BE in mechanical engineering, etc. Civil engineering also. And but there are some other courses are there which we call integrated meteorological training course or intermediate training course. They are BSc people. Their minimum qualification is BSc with physics and mathematics. But thing is, as your question is whether any BSc physics student can enter.
Yes.
Till now, it is a policy of India. Till now, the IMD training policy is that we entertain a person in IMD training, provided that person is directly or indirectly involved in some meteorological operation in some organization. That means, but definitely we cannot say we will not entertain. We can entertain. Suppose there is one student, say Mr. X, he is interesting. In that case, if only Mr. X applies that I am Mr. X, this is my I want to then it is the present policy does not allow us to entertain. The present policy allows that if that Mr. X is interested for a particular training, then Mr. X should bring a nomination letter or recommendation letter from the head of his or her institution.
Okay.
That means principal, even head of the department, that is okay. But something is required. This is till now our training policy says like this.
Okay. So one last question I have, in desert area, how efficient is the artificial rain production? Dubai recently have started.
Yeah.
So how efficient the
How we
efficient is an artificial rain?
No, first of all, for conducting the artificial rainmaking experiment, first of all, we should understand the physics of the artificial rainmaking process. Because what happened, the basic philosophy of artificial rainmaking is that over some place, moistures are available. Moistures are available, but those moistures are not able to get collected in the form of a cloud, because
Okay.
we all know that for getting rain, cloud must be there. Only availability of the moisture is not the only criteria. Okay, so that's why what happened, artificial rain making system, it enables it enables the available moisture to form rain cloud, and ultimately to get the rain. But your question is, suppose over a place, if there is no moisture at all, then in that case I don't think it will be very effective, and generally we don't do such experiment over such place where there is no moisture.
Okay. Okay. Very good. Very good explanation. Yeah. Thank you very much. So let me see if any question on the YouTube.
Yes, yes, yes.
So Madhvi or Vivek, anything there on YouTube?
No, not from YouTube.
Okay. So once again, Dr. Datta, it's very pleasant to interact with you and to get some experience about the meteorology. Thank you very much for this your valuable
And
time.
another one thing I have forgotten, that whatever meteorological educations are available in India Meteorological Department, that is a course.
Mhm.
These are now for the departmental. These are some employees, I should say. These are some employees or some students nominated by some UN organization, or students by some institution, or students by some university, like that. But now, recently, India Meteorological Department has started popular lecture series on different topics for the capacity development of the general public also.
Okay.
Already a couple of such YouTube lecture has already been completed. Just like one lecture was there, basic science of the weather forecasting,
Mhm.
basics of the science of weather forecasting. So like that, some lectures are already that we are also nowadays we are conducting on many fields. So actually this is the considering our commitment to the common people, to develop their capacity in understanding different terminology, different phenomena related to meteorology. And also, as you have asked the question, also we are working now that if it is possible, because after all you can understand it is a government department.
Mhm.
Every government department, there is some rules regulation is there are some checks are there. Okay, so we are now trying that whether the common students can be given opportunity to our existing courses, because nowadays what happened, our courses are very much open through our website. So
Mhm.
many students, many requests we are getting, that I am interested, but when we are telling them, if you are interested, kindly bring a recognition recommendation letter or nomination letter from the heads of your institution or your from your authority, then that they are not able to find out it.
Mhm.
So that means a common student, by seeing their transcript itself, whether it is possible to get them admitted in our courses. For that now we are working. I hope we may be successful, but of course there will be some checks on here, because after all it's a government department. There are government rules regulations are there.
So, Dr. Datta, you have covered very nicely about the courses, but is there any information about the job opportunity? How a person will get a
Yes,
job in IMD
good
department?
question. Yes, I am telling you. Now, India Meteorological Department in the scientific cadre, earlier there used to be two feeder batch. Two. One is in the staff cadre. They are still it is there. It is called scientific assistant. What is called scientific assistant? These scientific assistants are recruited through staff selection commission, and the qualification for that, physics mathematics of course is there, diploma is also there, in mechanical engineering other subjects are there. So, and it is published in the newspaper, and it is published in our recently. I can tell you, a couple of years back, India Meteorological Department has recruited about 1,200 such scientific assistants from the entire India. 1,200 is not a small amount.
Yep.
1,200. Again, India Meteorological will take. So this is, and for that qualification, as I told you, BSc. Now another one channel is there, that is in the officer cadre, straightway direct class 1 officer. We call that that cadre name, earlier it was known as meteorologist grade 2. I also joined like this, meteorologist grade 2, and this meteorologist grade 2 is recruited through UPSC exam. UPSC exam, that is their qualification is your MSc Physics, MSc Mathematics, etc. MSc in Electronics also. Then your civil engineering, mechanical engineering, etc. Okay, oceanography, etc. And it is also published in newspaper, in our website, but it is recruited by UPSC only, Union Public Service Commission. Earlier procedure was like that. One has to appear in a written exam. After qualifying that person has to appear for a viva voce, and then after medical test and all this thing, he or she is recruited, and after recruited as a trainee meteorologist. It is just like, it is similar to bar. In the bar also it is similar to bar, trainee meteorologist. And during this training period, earlier actually only stipend used to be given, not full salary, but now it is full salary. It is given. Government has changed the policy, but after this 1 year successful completion of the training only, they are recruited as a permanent meteorologist grade 2. These are the two feeder channel is there. Nowadays another one channel has also come, that is your direct. Now directly we are recently India Meteorological Department has recruited senior level scientists. I mean to say scientist C, scientist D, scientist D. Advertisement was there, and just it was interview. Advertisement and interview.
And this is for after PhD, right? The direct one.
No, sir, it depends. After PhD, yes. Scientist C also after PhD. This is after PhD. PhD or experience. PhD or some experience should be. Actually, PhD is treated as a 5 years experience, working experience.
Okay. That's what the Shefali Jaiswal was asking, that her PhD will be treated as experience or not.
Of course, it will be treated as a PhD. When there, I advise that when there will be an advertisement for the scientist C, she has to only see that required qualification, whether her qualification is matching in those desired qualification or not. If it matches, then definitely it will be considered.
Okay. Thank you very much, Dr. Datta.
Thank you.
I just received one more message. Let me see.
Yes, no problem.
Can a PG diploma in remote sensing and GIS be helpful course?
Of course, postgraduate. I am telling you, postgraduate diploma, at least. Of course, at least in the scientific assistant cadre, so definitely it will be there. It will be entertained. I don't know whether in the med grade 2 cadre, that is officer cadre, it will be there, because till now whatever list of qualification I have seen, I don't remember whether among them there was any PG diplomas there or not. But later on, India Meteorological Department may consider. Right now it is not there.
Okay.
But definitely in the scientific assistant cadre, it will be.
So I think she is already PhD, so she is considering about the officer only.
If it is a PhD, definitely for scientist C can apply.
Yeah.
Only thing is what happened, that is required qualifications should match. In the list of required qualifications, there may be many. So his or her qualifications should match with someone with that.
Okay. So I think I don't have any question more. So Dr. Datta, thank you very much for your precious time, valuable time.
Thank you.
So we stop here.
Thank you.